So good afternoon to all of you, my dear students. Welcome to another lab session. Today we'll be doing module 5, number systems. The concept is very straightforward and very simple. We'll be looking at the binary number systems, how to calculate between decimal and binary number systems. We'll also learn about the hexadecimal number systems. Calculate the numbers between decimal and hexadecimal systems. Why do we concentrate on hexadecimal number systems? Because your MAC address, okay, your hard-coded NIC address is hexadecimal, and so is your IP version 6. That's why we'll be concentrating on this. So, binary number systems, also known as base 2. Let's have a look at those. Our machines, our computers, our routers, our switches, the only language they understand is binary. So even the IP address that they can understand is a binary IP address. So as far as our machines are concerned, this is the IP address that they can understand. Look over here. For them, this is the only thing that they understand, 4 octets, and each represented in binary format. The switch also has the same, the router has got the same address at G000 interface, binary. The same goes for PC1, binary address, okay? The other end of your gateway of your router, the same binary address. PC2, the same binary address. That is what they understand, the machines. Now, if we as human beings have to go through this, okay, we may go crazy. So that is why we follow this, right? So 209, the binary equivalent is 11010001. 165 binary equivalent is 101000101. Okay, machines understand this. We need to convert it into decimal so that we can keep our sanity. Okay, so for example, gigabit Ethernet 0 interface of the router. This is the translation of the binary IP address. Okay, so the main idea being that you have to know how to convert quickly from decimal to binary. Okay, there's a reason why we have to know how to convert. Now, those things we'll study in the chapters ahead. But for now, you should know how to convert from binary to decimal, decimal to binary, hexadecimal to binary, okay? And then from again binary to decimal. Okay, so we should know the conversion. Remember that all our hardware equipment, this is what they understand, okay? And as network engineers, this is something basic that we have to know. Our binary mathematics has to be improved day by day and has to be really good. Remember, in IP version 4, we each address consists of 4 octets. 1, 2, 3, 4. Okay? Each octet consists of 1 byte. Okay? So 1 byte plus 1 byte plus 1 byte plus 1 byte. So how many bytes do we have in total? 4 bytes. Okay? Now, each byte consists of 8 bits. There, 209 consists of 8 bits. Count 1, 2, 3, 4, 5, 6, 7, 8. So these 4 bytes, that means 8 plus 8 plus 8 plus 8. 4 bytes means 8 times 4, 32 bits. Hence, the concept of 32 bits. So IP version 4 address is 32 bits. IP version 6 address is 128 bits. Look at that range extension. That's something, isn't it? Okay. So as network engineers, we translate these binary addresses into decimal binary addresses so that we can understand it. Okay. So why the maximum address that you can give over here is 255? Because 255, if you convert it into binary, will translate into 1111111. Okay? And it cannot go beyond 255. You cannot have an address called 256. That doesn't make sense. Okay? So this is just a little bit of introduction. Remember, IP version 4 consists of 4 octets. And each octet consists of 8 bits. So a total of 32 bits. I repeat sometimes the things I've told you earlier because repetition is good. IP version 4 address. How do you know which is for host portion and which is for network portion? Network portion means belongs to the network. Host portion means belongs to the devices. Okay. If you have, for example, 50 computers in your institution, then your host portion will start with 1, 2, 3 until 50. Okay, including the routers and the switches and everything. Network portion consists of the actual network portion of your IP address. Now you have to ask yourself the question, how will I know which one is the network portion and which one is the host portion? The answer is subnet mask. Subnet mask will be given to you. When the subnet mask is given to you, then you know, aha, if it's 255.255.255.0, that means 255, 8 bits, plus 255, 8 bits, plus 255, 8 bits. That means 24 bits is for network. And host is only 8 bits. So how many devices you can add in 8 bits? Maximum 250. Let's say for now 255. Okay, take into consideration 0 to 200 and there's a formula that we calculate actually from 0 to 255. Okay, if you calculate, we have got maximum. You cannot have an IP address for 255. The last IP address you can add is 254. I'll teach you how to calculate that maximum host you can have. Okay, we'll come to, I don't want to overburden you all right now, okay, so that you get scared. For now, remember that the subnet mask tells us, hey, now we know how much of network portion and how much of host portion. Okay, 255, 255, 255.0. That means 24 bits is for network, 8 bits is for host. Okay. 255, 255.0.0, that means 16 bits is network, 16 bits is for host. If 16 bits is for host, that means you can have much, much more devices. Get the idea? Okay. If it's 255.0.0.0, that means 8 bits is for network and 24 bits is for host. Means many, many devices and so on. Okay. So one way of knowing what is your network address and what is your host portion address is by subnet mask. Another way is what they have done over here. Look here, /24. Can you see? /24. /24. /24. /24 means, hey, in this address, 24 bits is for the network address. That means this is reserved for network address. We cannot touch. The only thing we can touch is this portion, the 8 bits. We can change the value of this. This value we cannot change. Get the idea? So you can either have the subnet mask, or they will give you the address like this, \24. That means, hey, in this address, I cannot touch this, I cannot touch this, I cannot touch this. That means I cannot change these 3 values. The only value I can change is the last byte, last 8 bits. So I can change the 0 to 1, 2, 3, 4, whatever address I want. Okay, same goes for this. 24 means this is network portion, 24 bits. Host portion, 8 bits. Okay, my dear students, I'll keep repeating this over and over again until it is second nature to you. Okay, and you will learn it very well. So, long story short, binary, decimal, decimal, binary. And we, as network engineers, should know how to convert them, preferably quickly. Okay? Now, binary position notation. You know that binary, as we say, is base 2. Okay? So, over here, in case of our binary, it's either 1 or 0. In case of our decimal, it is base 10. Now look at the notation of our base 10, okay, where the radix is 10. In base 10, in our decimal, it's very straightforward. We have got a position 0, 1, 2. So it starts with 1, tens, hundreds, 1,000. We study these things in school. So if a number is 1,234, it is having, for example, at the ones, it has got 4. At the tens, it has got 30. At the hundreds, it has got 200. At the thousands, it's got 1,000. Add them up together, you get 1,334. So this is the decimal numbering system, which we have been following since the beginning of our education. Okay, and it makes sense. It's the fastest way to calculate and quantify something. Now, unfortunately, machines don't understand this. The only thing machines understand is base 2, not base 10. So that is why the need for conversion. Look at our binary, which is base. See, this one was decimal. Now let's go to binary. In binary, the base is base 2, radix is 2. Okay, so there is a way to calculate. So again, if you know the position number from starting from 0, 1, 2, 3 until 7, so 2 to the power of 0, 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 3 is 6, 4 is 16, 5 is 32, all the way until 1 to 8. So if you can remember this position, okay, 1, 2, 4, 8, 16, 32, 64, 1 to 8, then conversion from binary to decimal becomes very easy. They're giving you an example over here. For example, you want to convert this number 1100000008 bits into decimal. Okay, so just put this number in their consecutive number spots starting from 1 ending at 1 to 8. Remember, you have to somehow try to memorize this in your mind. Okay, if you have done it as much as I have done, it becomes second nature to you. Okay, it's no big deal. We have done this in school. You just have to practice and bring it back. So all you have to do is calculate. Okay, if you have a 1, so wherever you have ones, just add up those because the zeros will generate a 0. So over here, the 1 is at 128 position and 64 position. So add them up together and you get the number 192. So the binary number 11000000, decimal equivalent is 192. Quick calculation. Okay. I remember, 10 years ago when I went for 10 years or more, when I went for my instructor training, our instructor was very much hard on us. He was telling us quickly calculate in your mind. Don't use a pen and paper. So you can practice this. Okay. So if you want to convert, for example, this binary value IP address consisting of 4 octets, 1, 2, 3, 4 to decimal, here, that's how it's done. Put it in its position value and then do the conversion. Put it in its position value and then do the conversion. Wherever there is 1, just add up that area. Wherever there is a 1, in this case, just add up that area. Okay, so you'll get the relevant numbers. So this binary IP address means 192.168.11.10. Okay. Now, these kind of conversions, small conversions, you may even get it in your final exam, the one which is not related to CCNA. So practice. If you haven't done these things in school, perhaps you need to practice. What about converting from decimal to binary? Again, this we learned in school. This is the easiest way to convert. Again, you have to memorize this number position. Starts with 1, ends with 128. So start at this section. Okay. Now, if the number given to you is greater or equal to this, then perhaps you can put a 1. Remember, it says over here if the decimal number of the octet is equal to or greater than 128, then you put a 1. Okay. If it is less, then you put a 0 and then go to the next number. If it is greater or equal to, then you put a 1 and then subtract the number with this number. And then you move to the next one. And repeat until you come to the last position. Okay. Let's do a test. Okay. For example, here, the number 168, decimal number 168, quickly converted into binary. So 168, is it greater than 128? Yes, it is. So put a 1. Then you can say 168 minus 128 is 40. So is 40 greater than 64? No, it's not. Put a 0. Then go to the next one. Is 40 greater than 32? Yes, it is. Put a 1. And then subtract 40 minus 32. You get 8. Is 8 greater than 16? No, it's not. Put a 0. Is 8 greater than 8? No, but it's equal. Remember, greater than or equal. So put a 1. And then subtract 8 minus 8. You get a 0. Since you get a 0, all the other positions will be 0. So conversion of 168 to our binary would be 101010000. Okay, that was fast way of doing it. If you practice this enough, this is what even I use. Okay, rather than this which we were taught in school. You remember back in school, this is how I was taught to do it. If we were taught how to do it in this way, then it would be faster. Okay, we can do it in this way as well, but then perhaps this would be longer. This is much more faster. So practice this, and after some time, you would be able to do this mentally as well. Okay, if you do it in this way, just take the numbers from here, and then you do the conversion. So routers and computers only understand binary, but we understand decimal. That is why our IP address is given in decimal format. Otherwise, computers, routers, switches, firewalls, they only understand binary. Now let's go to hexadecimal number system. Hexadecimal number system is base 16. Decimal is base 10. Binary is base 2. Okay, hexadecimal is base 16. Now, the reason we are studying hexadecimal is because we are going to use it in our IP version 6. IP version 6 are represented in hexadecimal values. Also, our MAC addresses, our hardware addresses on our network interface card, wireless or hardwired, any NIC that we have, the MAC address is also hexadecimal. Okay, so if this is your decimal values, this would be the relevant binary value, and this would be our hexadecimal value. So hexadecimal values start from 0 until 9, and then from 8 until F. Okay, so this is how we represent our hexadecimal values. Now, the question comes, how do you convert? Again, we studied these things in school, but perhaps we have forgotten. So before that, let's look at our IP version 6. Consists of 128 bits. Okay, so over here, each character over here consists of 4 bits. Okay, 4 plus 4 plus 4 plus 4. So here we have got 16. Okay, 16 bits. So 16 bits times 1, 2, 3, 4, 5, 6, 7, 8. 16 times 8 will come up to 128 bits. Okay, so over here, each octet consisting of 8 octets, your IP version 6, each octet is 4 bytes. Okay, oh, sorry, each octet is over here, every 4 bits is represented by a single, yeah. So over here we have got 4, 4, 4, 4, all the way going to 128 bits. Okay, over here, why do we have to know each octet is 16 bits? Why do we have to? Because usually our first 4 octets represent the host portion, sorry, the network portion, and the other 4 represent our host portion, usually. Okay, but we can change that. So this is what your IP version 6 address looks like. And frankly speaking, it's much more straightforward and easier to assign than your IP version 4. Because IP version 4, you have to do certain calculations, especially when you are subnetting, which we'll study in our future lessons. But over here, the subnetting is much more perhaps easier. Okay. Okay. Now, the question comes, how do I convert this hexadecimal value to decimal value? The idea is to first convert it into binary, and then from binary to decimal. Okay. So convert the decimal number to an 8-bit binary string. Okay. And then the binary is converted into a decimal. You have to group it into 4 starting from the rightmost position. For example, 168 is first converted into binary. So 168 is converted into binary. Then take it into 2 groups of 4 binary digit position. Okay. from the rightmost position. So there you have got 1010 and 1000. So now you have these two binary numbers converted into their hexadecimal equivalent. Okay, so you have to look at this table. 1010, okay, that would be A. And then the other one is 0010, that would be 2. So what is the equivalent of hexadecimal value 168? The equivalent over here, yeah, that would be 1010 and 1000. That would be, I made a mistake, 1000. That would be 8. So the equivalent would be A8. Okay. So that is how we would be converting it. Yes, A8. I've got another example over here. This is converting from decimal into hexadecimal. Remember, you cannot convert directly. First convert into binary and then binary to hexadecimal, and vice versa. The vice versa is also the same thing. What you have to do is convert the hexadecimal number to 4-bit binary strings. Okay, for example, your hexadecimal number is D2 converted into binary string, that is 110 and 001. And now that you have this, okay, you can convert. You see, your D is 1110 and your 2 is 0010. Now you can convert this whole thing into a 8-bit, you can convert this 8-bit binary into a base 10. That would be 210 in decimal. Okay. So it would be wise to try and remember this mapping, okay, between binary and hexadecimal. Okay. So we learned that binary is base 2, decimal is base 10. Binary is what our devices understand. Hexadecimal is the number system that goes from 0 to 9 and A to F. And our MAC addresses and IP version 6 addresses are represented in hexadecimal. Okay, IP version 6 addresses are 128 bits. Okay, 128 bits. That will be having a huge range consisting of 16 bytes and IP version 6 address. Okay, and every 4-bit is represented by a hexadecimal digit. Okay, for a total of 32 hexadecimal digits. Yes. To convert hexadecimal to decimal, first you have to convert it into binary and then convert the binary into decimal. To convert decimal into hexadecimal, first you have to convert it into binary and then convert it into hexadecimal. Okay, so we'll be doing some practice exercises on this as well. Now, do you have any questions, my dear students, related to this?
Nope.
No.
When was the last time that you all did calculations like this? Perhaps if you are rusty, you have to practice.
Last semester.
Last semester, very good. Then you'll be fresh now. Okay.
Just a day ago.
Last semester, I think, yeah.
Very good. So you'll be fresh because an important aspect of this unit is conversion between two number systems, primarily from binary to decimal. Okay, and primarily for our IP version 4 conversion. Okay, good, very good. Any other questions?
Nope.
Who was this? I never did it. Hamza did it for me. Okay, very good. So you can ask Hamza to do it for you this semester as well. Okay.
I have no idea what he's talking about, sir.
Yes, I believe you.
Academic
Let's stop.
misconduct.
Let me stop the recording, okay? Let's not make it more controversial than it is.